Right, this video is for the questions in the 40s. First one I was asked to do is this multiple choice question here, number 40. Unfortunately, there's no quick way. You're just going to have to do them all. To work out the mass, when you're given the volume, you're going to have to go to moles. So to go to moles, you're going to be dividing by 24,000 because they're giving it to you in centimetres cubed. And once you know the moles, you're going to be timesing it by the formula mass to work out mass. So for formula mass of argon is 40, oxygen is 32, 28 for N2 and 20 for neon, and when you work them out the answer ends up being C, so that's just trial and error. The next one, 41, you're taking potassium hydroxide, calcium hydroxide, mixing them together and working out the OH minus concentration. So in most cases I'm going to be finding moles, I've got volume and I've got concentration, so I'm going to be multiplying them. Before I multiply, I change my volume into decimeters cubed. So I work out the number of moles of KOH I have, and in KOH there's only one equivalent of OH minus, so just kind of timesing it by 1, so that's the OH minus I'm getting from KOH. With CaOH2, I've got again volume times concentration, but this time when I work out the number of moles, I'm timesing it by 2 because there are 2 equivalents of OH minus for every CaOH2 I've got. So that's how much I'm going to get from calcium hydroxide. And I'm mixing these two together and I want the total, so I'm adding these two numbers and I get an answer of D. 42. This is just how pipettes are calibrated. You may remember when you did your titration, when you're using a pipette, there is always a little drop in the end. The pipettes are calibrated to account for that drop. You are not supposed to try and force it out, and you're not supposed to ever go above the graduated line to compensate it. So the answer is B, you just leave the droplet in the tip, and the instrument is calibrated with that in mind. Next one is here, 45, so it's a titration calculation. There's lots of information down here, okay, as well, but I'm just going to go through it here. Ultimately, what you're asked to do is work out what N is. So you've got glutaric acid. They've given you this formula, and you're asked to work out what N is. You're titrating this acid against NaOH. First thing they ask you to do is just fill in the titration readings, which you can also get from the mark scheme, and calculate the mean. Remember, you're only using concordant results. And this value here, 18.25, is the volume of the sodium hydroxide that was used in this titration. You're told the concentration of sodium hydroxide that you use. And using this, you can work out the number of moles of sodium hydroxide, and then using your ratio, which is 2:1, you can work out the number of moles of your acid. Now, you are told that this acid, you had 25 centimetres cubed when you did the titration, so you've just worked out the number of moles in 25 centimetres cubed, but as we so often see, the solution was originally made up to 250, so I need the number of moles per 250 centimetres cubed. Therefore, I'm taking my value for 25 and I'm multiplying it by 10. So this is the number of moles I've got in 250 centimetres cubed. We've got the mass per 250 centimetres cubed. So now I've got mass, I've got moles, I can work out the formula mass, and that formula mass for glutaric acid is 132. But you're asked to work out what N is. Now, you're told glutaric acid has 2 carboxylic acid groups. Each carboxylic acid group has a formula mass of 45. Because there are 2 of them, that accounts for a mass of 90. So if I do 132 minus 90, what I'm left with, the 42, must represent the CH2. But how many CH2s can I have? Well, each CH2 has a formula mass of 14, 12 from the carbon and the 2 hydrogens. If I've got 42 in total, I divide that by 14, there must be 3 CH2s, so N equals 3. I was also asked to do question 48. So this was a, was it 5 or 6 marker? 5 marker. You've just been asked to prepare a standard solution. So most of it is just you writing out how you prepare a standard solution, but there is a calculation involved as well. You're trying to prepare 250 centimetres cubed, and you're told the concentration. If you're given volume and you're given concentration, you can work out moles, the moles of barium hydroxide that you would need. So it's going to be volume times concentration. This is the number of moles. But in the lab, you're not going to be able to measure out the number of moles of barium hydroxide. You need to measure out the mass. So once you know how many moles you need for this concentration, you times it by the formula mass of barium hydroxide and you work out the mass. Once you've worked out the mass, you need to describe how you'll do this practical. So you'll say you'll measure out 6.42 grams using a mass balance. You'll transfer the mass into a conical flask. You'll rinse your beaker with deionized water. You'll continuously add in the rinsings, and then you'll make the solution up to the line using deionized water, reading from the bottom meniscus at eye level, put in the stopper, invert, all those kind of details to make sure you're getting full marks. It does say in the mark scheme that students lacked detail in their answers. It's a nice question if you're asked just to make a standard solution, so make sure you can give adequate detail. Next one, another titration question. This one about how much lime you get, how much citric acid you get in a lime. Again, you're doing a titration. So you read your burettes. Remember, you're always reading from the bottom of the meniscus, and all of your values must be to 2 decimal places. Then using the concordant results, which in this case are 27.3 and 27.4, you're working out your mean titer. And then you can do your calculation. So you've got the citric acid, which you're getting from your lime. You're titrating it against NaOH. NaOH was in the burette, so the volume is coming from your mean titer. You're told that the concentration of NaOH is 0.8. Volume times concentration is the number of moles, and you can see from the ratio here that it's 3:1. So this is the number of moles of acid you had in 25 centimeters cubed, but you made up your solution to 250 centimeters cubed, so you're going to have to times this by 10 to work out how many moles you had in 250 centimeters cubed. You can then work out the mass of citric acid you must have. So you've got your moles, and you have got the formula mass of citric acid. You times them and you work out that you must have 14 grams of citric acid in 250 centimeters cubed. But the actual question is asking you to calculate the mass of citric acid in 1 lime. If you read from the top, you squeezed 2 limes, so you're going to have to divide by 2 to work out how much citric acid you have got in 1 lime. Just the second part of that question there, they're saying using that concentration of sodium hydroxide is dangerous. The teacher wants to use 0.2 instead. So if you're using 4 times less sodium hydroxide, you should be using 4 times less citric acid. So rather than using 2 limes, you could just use half of 1 lime. Or the other thing they accept in the mark scheme, rather than making the solution up to 250 centimeters cubed in a volumetric flask, you could make it up to 1 decimeters cubed. So you're kind of diluting it 4 times more. If you're diluting the sodium hydroxide 4 times more, you should dilute the citric acid 4 times more to keep things in the same ratio. And that was the end of that section.